Hello, everyone. And okay, so quite a few people joined. So today, a different format. I will be doing a Q&A, and I'm going to share my screen. Here you are. I'm doing a Q&A today, so you can ask me about any questions on assignment 4 and physics or maths. I will, well, I won't give you the solutions, but I will I can answer your questions about the questions, maybe give slight hints towards how to do something. So yeah, so far away, any questions about any of the assignments? Maybe particular question you're stuck on, you'd like some guidance, go ahead. So maths 1204 and physics 1204. They're quite similar in a way. And we'll probably finish by 7 today, but if needed, I'll do more. All right, physics problem 13. Physics problem 13. So starting from the end, okay. That's an extra problem. Okay. Physics 13 and then physics 10 afterwards. Okay. Okay. Two light rods, A, B, and BC, are hinged to the wall at A and C, and also hinged together at B. A mass 100 kilograms is attached to B. Find the tension in each of the rods. Well, I mean, you just need to draw the forces at B. You just need to draw the forces. So there's mg. There's the tension. Now, you don't know whether tension, you don't know which way is tension, so you just guess. So I'm assuming the tension from here is going that way, and the tension from here is going that way. So that is T, let's call it T1 and TB. You split TB into components, and you just find it. No, it's quite straightforward, straightforward question. The vertical component of TB is that, and the horizontal component is that. But yeah, I don't know how to find tension because I keep having too many unknowns. Well, there's only two unknowns, T1 and T2. You have two equations and two unknowns. That's fine. This is T2 cos theta, and this is T1, T2 sine theta. And that's it. That's nothing. So the unknowns, so you have two equations, one for the horizontal forces and one for the vertical forces, and two unknowns, T1 and T2. So, right. Physics question 10. I hope, does that help? Risham, does that help? Okay, problem 10. A uniform hemisphere of mass m1 is placed on a curved side down on a horizontal surface. A small mass m2 is placed on the edge of the circular face. The hemisphere tilts slightly. Find the angle of the tilt. Okay, well, the idea here you have a hemisphere that is tilted, and you have two masses. This is m1, and this is m2, the mass. Hemisphere tilts slightly. Find the angle of the tilt. So if you draw, if this is the center of the hemisphere, you draw a line like this. This is the pivot. And you have two forces. You have F2 and F1, and just find yeah, just not you do F1 D1. This is D1 is equal to F2 D2. D2. Hope that helps. Does that help? Who's Abiola? You just need to very carefully think of this is the center of the mass, of the hemisphere, and this is where the second mass is. So you just need to balance it. Yeah, basically. Raghav, I had a general question not related to this. I want to know pursue a computer science course. Regards the math, I know that we get a lot of PAT problems, but would they be of a similar level if you kind of compare to the math problems? I honestly haven't done much math problems, but I understand from my feeling is that the math questions are slightly harder than the PAT maths questions, if that makes sense. So I would practice math separately. Yes. If you need the math, you definitely do math past papers. Physics past papers also help, but they are targeted for physicists, right? So we are, and our course is targeted for physicists. We give the maths. Well, you saw the maths that we do in the maths assignment in it really helps you to get to grips with the physics. Okay. Maths problem 6. Maths problem 6. Let's have a look. Well, you just draw it. And then give the answer in terms of n. I don't know, let's where n is a positive constant. So just yeah, imagine it was a different set. Let's say y equals nx where n is greater than 0. Y equals -3 and modulus x equals, I don't know, 7. You just draw the lines. So first you draw y equals nx, that's going to be like this. Y equals -3, like this. And x equals 7, that's like this and like this. So I'm guessing this area. So once you draw it, it becomes straightforward. So That's my advice. Draw. I had it's okay. Did you try to do the yeah, do try again. You only have 2 unknown. Just focus on the T1 and T2. So on the math assignment, where it explains integration by parts, should the minus not be a plus when explaining and it giving the example with the product rule? Right, math assignment, integration by parts. That is page 6. Yes, I am very sorry for that. Yeah, it is plus. I'll change that. I'll change that right away. So sorry for that. My bad. So maths 1204 integration. What am I? Page 6. That's physics. What? Change that, but yeah, it won't change on the website for now, but for the future it will be different. And okay, so well, Rahul, try n equals 2, then try n equals 3, then try n equals 4, and see if there's a pattern. I have a general question, even though COMPOS is targeted towards a personal. I would definitely include that. But when you do it on a personal statement, please do don't just say I did the COMPOS. Yes, because we're still a young program. We've been active for 2.5 years. So you would please say it as I did a COMPOS program, which is an online school from the physics department of the university. As part of COMPOS, I had to do 5 hours of physics and maths per week for a whole year, right? So it just make sure you explain what it is, right? And if they know what we are, then great. But if they don't, they get a feeling. What did you do? Oh, I did COMPOS. So what is it? Is it like an hour lecture that you attended, right? So just make sure you explain what we are, because different activities have different weight, and COMPOS certainly is a very serious undertaking. And if you went through COMPOS, that would definitely help your maths personal statement. For problem 3 of physics, could you please explain why the fly moves up the tube? I'm not sure it moves up. Um, oh, the fly flies. So you could view it in a you can do it in a different method. Like you could think of the fly as being stationary and the tube falling. Right. So in the beginning, we have the tube is like this, and the fly is like this. And at the end, we have the tube like this, and the fly is like this. So technically, the fly hasn't moved. Yeah, it flaps its wings before and after. So yeah, it hovers, yeah, or jumps, whatever it does, it won't change the answer, right? Even if the fly has a mini jetpack or a battery, solar battery powered, whatever, it won't change the answer. Even if it has a small nuclear device that blasts her from the bottom of the tube to the top of the tube. Yeah, the fly's mass is m, which is the same as the mass of the boiling tube. Mass m and mass m. So you're given the mass. Just to be clear, if we say mass m, you assume that you know m. You know m. So you give your answer, you can give your answer in terms of m. Physics 11 and 12. It's just moments. I mean, what's the difficulty? Do you have any specific difficulty? Just you have a triangular plate, and you have person A, person B, person C, and they all hold it like this. And then the plate has a center of mass and it's going down, mg. So you take the moments. Let's say take moments. Take moments about point B, for example. Yeah, why not? So B is the pivot. And then you have this distance, d1. Then you need this distance, which is d2. So d1 times mg is equal to d2 times f1 plus f2, fa plus fc, right? So, but the fly's mass is definitely relevant. Biola, does that help? I mean, does this diagram help? Oh, okay. Try finding a video on how to use moments. Yeah, a good video on moments, maybe Khan Academy. Let's see if I can find something straight away. Moment of a force. Of a force. Well, this one is a good to start with. It's quite easy, but it's a GCSE physics. But then, yeah, this is another example here. Oh, this is a good example. Looks like this one, UK maths teacher. So we can try this one. Okay, that's too complicated. You don't need that much for now. Well, yeah, just try searching. Sorry. And we do have some information in the assignment, so you look carefully through the assignment. So go with example 5. It's very similar to problem 11. Okay, so you can do problem 11 just like example 5. Now, but you replace the triangular rod with a flat rod. So this is B, this is A and C together. So this is MG. This is the pivot, and this is these are the two forces, F1 plus F2, FA plus FC, sorry. And then just take the moments around point B. Hopefully that makes sense. Number 12, same logic. Absolutely the same logic. We have a pivot. So we have the gravitational force, mg, and we have the buoyant force, which is here. And then you just take the moments. So this is d1 and this is d2. This is F buoyancy. So d1 times mg is equal to FB times d2. Buoyant force. I might have spoken too much. Okay, I'll delete that. Forget it. It's correct. It's just too much information. Is the fly's mass relevant? Yes, it is, because this is a center of mass problem. And you need to use the property of the center of mass. Think of the boat problem. If you're on a boat and the boat is in the water and you're walking from one end of the boat to the other end of the boat moves backwards. Do you think your mass is relevant in this problem? Oh, yes, it is. Because if you are heavier, the boat moves further back. If you're lighter, the boat moves a smaller distance. So this is a vertical version of this problem, but plus both the fly and the boiling tube are affected by gravity. So the fly must be pushing in order, because the boiling tube falls in time t, right? So the fly is flapping its wings and thus pushing the tube further down, right? Because if it's moving its wings, there's a down thrust of air, which is pushing the boiling tube faster down. So the boiling tube should be accelerating faster than G. Interesting. Yes. Could you explain example 6? Happy to. That's a good question because I can do example 6 from beginning to end. Oh, sorry. Is it maths? I'm assuming that's maths. Okay. Example 6. Example 6. So this is a sphere, and what you do is you cut the sphere, you slice the sphere, and if I'm any good at drawing, if you slice the sphere, so let's take a slice of the sphere. The slice of the sphere will look like this. So it will look like bam, 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 bam. So it's something like a truncated cone, but isn't a cone. It's somewhere, it's like a cylinder. It's almost like a cylinder. So if you flip it, if you flip the slice, it's almost like a cylinder. So you can say that it's approximately a cylinder. And you can think of the sphere as being made of many cylinders of different radii. Yeah, so that's the idea. So if you take many cylinders of different radius, you can make them into a sphere, right? Just like a 3D printed sphere. 3D printed sphere. Printed sphere. So you can see that they are made of circles in this case, of rings of different radius. So the same idea applies here. Okay, now this slab, the radius of this slab is 1 minus x squared. How do we know that? Well, because this equation, the equation of this line, is a circle. So it's x squared plus y squared equals r squared. So, and r is 1. So that's equal to 1. So y is equal to square root of 1 minus x squared. So this is y equals 1 over 1 minus x squared, but it is also equal to the radius. So r is equal to 1 minus x squared. Okay. So the volume, the thickness of this slab, so the radius is square root of 1 minus x squared. The thickness of the slab is delta x. And so the volume is pi r squared h. That's the volume of a cylinder. And that's equal to, let's do the VI, let's call it VI. It's the ith slab because there are many, many slabs. So just this particular one. It's going to be pi multiplied by 1 minus x squared multiplied by h, which is delta x. Okay. Now, the ball consists of many slabs, many cylindrical slabs. So the volume of the sphere is approximately equal. Now, this is an approximation. Is approximately equal to the sum of all VIs. This is VI, the volume of one slab. It's the sum of all slabs where I is from 1 to n. Is if it's cut in 8 n slabs. Cut in n slabs. Now, this is equal to I equals 1 to n, and VI is pi 1 minus x squared delta x. Does everything make sense so far, Raghav? Okay. Now, the problem is that it's an approximation. To make it equal to sphere, we need to make the slabs infinitely narrow. So the size of the ring has to get very, very small. So it is exactly equal, the volume of the sphere is exactly equal to the limit as delta x, the thickness of the slab, tends to 0 of this expression of the sum of I equals 1 to n pi 1 minus x squared delta x. And the limit of that turns out, and Riemann proved that, so the sum symbol becomes the integral symbol, pi 1 minus x squared, and delta x becomes dx. And the limits, well, you just apply the limits that make sense, which is from -1 to 1, because your x changes from -1 to 1. So -1 to 1. And then you just integrate that. So pi, and then x minus x cubed over 3 between limits -1 and 1. And you go pi There's something I don't like about it. Okay, pi 1 minus 1/3 minus, oh, plus 1. Yes, that makes sense. Okay, plus 1 minus 1/3. Okay. I was scared that it's going to be 0. No, it does make sense. So that's 2 minus 2/3. That's 4/3 pi. 4/3 pi. And indeed, the volume of a sphere is 4/3 pi r cubed, which is consistent with the formula. This is consistent with v is equal to 4/3 pi r cubed, because r equals 1. Yeah, does that help? Did that help anyone else? Apart from Raghav? No, you don't necessarily need to explain the conjecture. Just make the conjecture, and as in I think, like here, what would the conjecture be here for a sphere of radius r? And it's 4/3 pi r cubed. You can test your conjecture, right? So you can test your conjecture and see, does it make sense if you use it? For physics problem 14, physics problem 14, if mu is a much larger number, that basically means the cylinder is stuck like glue. No. Mu is greater than 1 means that it won't slip, but it will roll. If mu is small, that means it can slip. Can slip or roll. And this one means can only roll. Can only roll. Imagine it's like a gear. It's like a gear on a gear. So it can't slip, it can just roll. If you hold it upside down, it will fall. Does that answer your question, Resham? Don't be shy asking publicly. I mean, you can ask me. You don't need to. You don't have to use direct messages, because otherwise, other people don't see the questions. They might be wondering as well. Okay, for the question where it says erratic conjecture, do we need? I would test your conjecture, but you don't need to explain, as I said before. Okay. Does that help? As a cylinder rotates. Okay, for both questions, you need to find the angle at which it will slip and the angle at which it will roll. If it's rolling, then you don't consider the friction force because you're taking moments. You when you're trying to establish whether it's going to roll or not, this is your pivot. This is your pivot. This is your, and this is the center of mass. This is the center of mass of the disk. It will be balanced like this. So you want to work out at what angle will it roll, and you don't need the friction force here. You don't even need to consider the friction force here. So first, find the angle at which it will roll by considering center of mass and pivot. C problem, I've done this. I've done a very similar problem here when we were talking about the doll. Remember, the doll has a center of mass, and yeah. So rewatch the problem 6. See problem 6 previous. See problem 6. 6 on the left. And then second, assume a point object. Find the angle at which it will slide down. With the friction, yes, the friction will always be up the slope, but because you're taking the friction at the pivot, you don't care. Yes, this is the force of friction. Friction is up the slope, but it's the pivot. You don't need to take moments about the pivot. You don't need to take moments full stop. You don't need to take moments for this question. Yeah. It's more like a common sense geometrical question. Just think of the critical situation at which the ball will roll down. And this is related to the center of mass. So you need to find the center of mass, of course. So yeah, that's that. All right, more questions. Next question. What is the context of the next assignment? The next assignment is going to be, let me have a look. So maths is going to be series. Ooh, it's a hard one. It's one of the harder ones. And for physics, we are going to have momentum. Momentum in series. I think this schedule is on our website. There were some changes, but you can get a general overview of the program. Good question. I think an experiment is needed. So heavy. Ah, yes, I got it. So, where's my video? So a hollow, this is a Pritt stick thingy, and I'm attaching some blue tack to the bottom. Okay, so blue tack and thingy. Now, if I place it on a surface, it's bounces like this, right? Now, if I put it on a rough surface and keep tilting it, it's slid. I don't know if you've noticed, but it slided. English was never my strong side. You see, it slides. So that means the friction is not enough to hold it. Now, if you take a surface that is more rough, something rubbery. Well, I think you got the idea. So you can see that it tilts. Once it tilts, and then I don't think I have a rough surface. That's annoying. I wonder if this would work. Okay, if I tilt faster, it will roll. I want to get it to roll eventually. So at some point, it will just roll down. So you want to find the angle at which it will start rolling and the angle at which it will start sliding. Now, the angle at which it will start sliding doesn't matter how you put it. You can put it in any form. It will still slide at the same angle. You can do this experiment at home with this. Yeah, so put it just on the side and find the angle, and put it on the side like this. The angle should be the same because it's, and yeah. So hope that makes sense. Does that help? I love improvised physics experiments. Okay. All right. Any more? Anything else? Just one more thing, that if you tilt by I don't know, 10 degrees, the cylinder will tilt by more than 10 degrees. That's how it stays upright, because you need to counteract. Basically, there's a moment produced by the gravitational force, and it will tilt further to counteract this moment. So, right. Yes, that's fine. Well, I think we'll be wrapping up then. I don't see any questions. So then I assume that you've done everything. I'll see you next week. And yeah, hopefully this helps. Hopefully this was useful today. Please do comment if you found this useful or not. And see you all next week. And we're going to be talking about the next assignment, momentum and series. Momentum and series. See everyone. Welcome.